Hello everyone. In this video we're just going to go over some basic definitions and focus on sample spaces and then the multiplication principle. So first let's talk about some of these basic definitions. So the main things we'll be thinking about when talking probability in general is we'll start with an experiment, right? So this is just going to be some procedure with a defined set of outcomes. So a lot of the ones that we'll do will be rolling dice, flipping coins, drawing cards. You can talk about sports, right? Shooting a basketball has a defined set of outcomes, right? You make or you miss. So that has two outcomes there. These are all examples of experiments. You can also combine any of those, right? You can do them consecutively. You can roll a die, then flip a coin, then shoot a basketball twice, and then draw two cards or something like that, right? That could be one single experiment. So then the sample space is the set of all possible outcomes of an experiment, right? So as an example here, if we flip two coins, then our possible outcomes are either both heads, heads tails, tails heads, or tails tails, right? We have four possible outcomes in this case. And so this set with these four elements would be the sample space in that case, okay? And then an event is basically, you usually want to be thinking this is what we would define as a success or something, right? Or something you want to determine the probability of. It could be, a failure as well, right? What is the probability of missing, however many shots? You could certainly want to look at that. So this is just a subset of the sample space, right? You just want some collection of things that you're focused on out of all the possible outcomes. So gave a couple examples here, right? So if you roll a pair of dice, rolling two threes, if you want to figure out the probability of that, like that is an event. Or drawing a red card from a deck of cards, right? That is an event, and it's an event that occurs with 50% likelihood, right? Because half the deck consists of red cards. So now we're going to talk specifically about independent events and how this relates to the multiplication principle. So this is going to be something that tells us how big the sample space will be in general. So let's try to analyze this through an example. So let's go ahead and draw a tree diagram to see kind of what all the possibilities are here. So first we have two options, right? We flip a coin and we either get a heads or a tails. From there, the second roll does not depend on the first one, right? The die has nothing to do with the coin that you flipped. This is what makes them independent. These two things do not affect one another. And so, after you have flipped a heads, what are the possible rolls you can have on the die? So here we see, right, we can roll anything from a 1 to a 6, and this applies to both first flipping a heads or flipping a tails, right? So basically we see two options up here, and then for each of these two options we see 6 per down here. And so this is how we get a total sample space of 6 times 2 options, right? These are two independent things. For each of those two, there are 6 options, thus we multiply them together. And of course you could just count them up as well and see how many are down here, and you're going to see that there are 12. Okay, and so this is how big the sample space is, and this works in general. So this is what we call the multiplication principle. So it says if we have two independent events, and it's very important that they are independent, one with m possible outcomes and the other with n, then if you do them both, you just multiply it together and you will get m times n total outcomes. And this generalizes, I'll just give a little note here, this generalizes to any finite number of independent events. So it doesn't just have to be 2, okay? So if you have like 20 flips of a coin, then you can just multiply 2 20 times. And so you get 2 to the 20th as the size of your sample space. So let's do a couple of examples, and I'll have you guys do a couple exercises. So in this case, our experiment will be to roll a die, then draw a card from a standard 52 card deck, and then flip 2 coins. Okay, so first I just want to give some examples of events. So again, these are just examples. There are plenty of different things, right? So what would this look like? Well, we basically have like 4 things going on, right? So I could say roll a 3, draw a heart, and then flip exactly 2 heads, right? So like this would be an event. Another thing would be like roll an even number, right? Draw a black card, either a spade or a club, and then roll. I can just kind of put these together and say 1 head and 1 tail, right? And so these are just examples of events, and you could, once you figure out all the possible outcomes, see how many of them correspond to these. So let's see how many things are in our sample space. So first of all, note that these are all independent, right? Nothing is depending on the others or impacting the others. So we have 6 options for the die. We have 52 for the card. And then we have 2 for each of the coins. And this turns out to be 1,248 total outcomes here, okay? Okay, so this one is going to put together kind of all of the things we've talked about. So this is the first exercise. So here the experiment is to flip a coin, then roll a 3-sided die labeled 1, 2, and 3 on the 3 sides, and then flip a second coin. So first I want you to give examples of 2 events where at least one has more than one outcome. So you shouldn't just say like heads, 2 heads. There should be at least 2 outcomes in one of your events. Second part, how big is the sample space? And then you should kind of verify your answer and show all of these outcomes that you said should exist using a tree diagram. And this shouldn't be too big, it should be very drawable. And to close things out, we mentioned in class an idea of an example of a dependent event. And we talked about drawing things without replacing them, right? So in this case, I want you to kind of think about both options. So if you draw 2 cards, how many outcomes are possible if you do replace the card you draw and put it back in the deck before drawing the second? And then how many options are there if you do not replace the card that you draw? So you keep it out and then just draw again from the deck without that card. All right, so that's all I've got. Thank you for watching.